Okay, now I'm just going to go through packets. What exactly is a packet? You'll see there's a lot of packet. In networking, they refer to a packet quite a lot. A packet is basically the smallest, what do you call it, bundle of information that data gets transmitted into. If you load an image in a browser, or you download a video, or you download a movie, or you download a game, it all actually gets broken down into smaller packets. And these packets are actually very small. Most of the time, I might be wrong here, but I think they're about 1.4 kilobytes. It's the maximum size of the packet. So if you download a video, you're sending like millions of packets to the internet to download that video. It's just easier, instead of sending a massive chunk of information and trying to track it as it goes to the internet, it's just easier to track smaller chunks of information. And those smaller chunks are called packets. Now a packet consists of the data in the packet, and that's what we call the payload. So if you have a video, we'll actually take this video and we'll create very small pieces. Now each piece that's part of the video is also part of the payload of the packet. It's actually the data that this packet is carrying is going to the internet. And there's also a lot of other information, such as the protocol. That's basically it's TCP, UDP, ICMP, etc. There's a source IP address and port where this packet comes from. This is needed if you want to, if the packet goes to a certain server or to a certain device in the network, and that device wants to reply, it needs to know what the source IP and the source port is, so that it can reply to that packet. We'll get more into it when we get to sockets and connections. Then there's the destination IP and port, obviously where this packet should go to. So as this packet travels through the internet, servers and gateways along the way needs to open and look where this packet is going and then route it accordingly. It's almost like post. When you send post, you post a package to America or to the UK or to Australia, every post office will take the package, will read the address on it, and then it will route it accordingly. So it's very similar how a packet works. A packet can also be compared to a postal package. There's also lots of other related packet info based on the type. Basically, the last one will explain that there's different layers around this packet, depending on the type. This is an example of a packet. A lot of people compare a packet also to an onion. It's got the core, which is the payload, and then all those layers around it. Okay. And as it gets sent from one place to another, some of the layers will be stripped and put back. Obviously, as it gets packaged, it will start with the data on the wrapper, or the first layer, give it to something else, the next layer, give it to something else until it's complete, then it will actually send it to the network. Okay. To give you an idea of these layers is actually the network layers, which we will get to in a short while. We're going to do these first, then we'll get to network layers. We will actually go into the layers of a packet. This is obviously a packet is an array of bytes, or you can actually see it as a list of bits. Bytes is obviously your smallest data carrier in computing. It actually represents a number. Obviously, a byte contains 8 bits. Most of the time, you don't really use bits because it's a bit of a mission, so we usually use bytes. Everything's referenced with bytes. So a packet is actually just one long array of bytes. So in here is a lot of bytes. So there's a couple of bytes there's a couple of bytes there's a couple of bytes there. Obviously a lot of bytes there, more bytes there, and there. So the whole idea is that your payload is just a string of bytes. Obviously it's got a certain format that gets saved in so that the remote side would know what the bytes mean. And each layer can put a certain byte in front and at the back of the payload. So it just gets longer and longer. Some of the layers only put stuff in front as well, and not anything in the back. So it's not completely layered, it's sort of more one-sided. But it can put it on both sides. And that's where the layering comes in. So as the packet basically goes through the different processing of building it, these layers get added. Okay. Cool. Does this make sense? Obviously the green is one layer, the blue is another layer, and the red is another layer. Does this make sense? Do you have any questions about the packet itself? Everybody fine? Cool.